In this video, we're going to continue looking at quadratics and in particular continue our discussion about graphing them. So this is an example from Math Excel. I have an equation up here of the quadratic, and we know that it's quadratic because it has the x squared. First thing that I need to do, as always, is identify my a, my b, and my c. So my a is the number in front of x squared, which is 1. My b is the number in front of the x, and I take that sign with it, so it's -5. And my c is the number that does not have a variable, so that is just 6. Now, when you're asked to fill in a table, the one key thing is that we want our vertex to go into the middle of our table. And when we graphed lines last year, we would pick 3 points, and then once you had the 3 points, you could draw a line through it. With quadratics, we want to start with our vertex because, as we saw yesterday, you have to first graph the vertex and then graph one other point. So from yesterday, to find that vertex, we're going to have to use the equation x equals -b over 2a. When I use these numbers, I'm going to take negative times -5, which is +5, and 2 times my a, which is 1, so that gives me 2. So this is going to be 5 divided by 2, or 2.5. So I can enter here 2.5. That's going to be the x value of my vertex. To figure out the y, I need to use this equation and plug the 2.5 into each of those x's. And I've already entered this information into my calculator. Again, whatever number I fill in, this 2.5, I'm going to put it in parentheses and then square it -5 and then put that value in parentheses again, +6, and I get -0.25. So I need to enter that here on my table, -0.25. Right, filling in the rest of the table. If this number in my vertex, if the x value of my vertex is a whole number, I'm going to subtract 1 and subtract 1 to get these. I'm going to add 1 and add 1 to get these two values. But because this is a 0.5, if I were to subtract 1, I'd be at 1.5. And then I'd be at 0.5. And I really don't want to have these decimals. So I'm just going to subtract 1/2. So that's going to bring me down to 2. And then I'm going to subtract 1 from there to get me to the next whole number of 1. I'm going to do the same thing on the other side of the table. So I'm going to add 1/2, which takes me up to 3, and then I'm going to add an entire unit, which takes me up to 4. So it's very important that the smaller numbers are at the top of your table, the bigger numbers are at the bottom, and where this is 2.5, we're going to go 1/2 unit and then a whole unit, 1/2 unit and a whole unit. Again, if this is already a whole number, then I would just go 1 unit away, 1 unit away, making sure that the small values are at the top, big numbers are at the bottom. Once I have these, I'm going to enter these numbers into my calculator to get their values. I have entered all 4 of the values, -1, 2, 3, and 4, into the equation in my calculator, and you can see the answers that we get. So I'm going to put these into the table. So it was 2, and then 0, and then 0, and then 2. Now, going back to this calculator, you should see this pattern as long as these numbers are the same distance away. So we went up 1/2 and, well, less 1/2 and then less a whole unit, and then we went 1/2 more and a whole more. These two numbers should match up, and these two numbers should match up. If the values you're getting do not match up, you're going to want to check this vertex, because if it's in the center, this is talking about that axis of symmetry where these values need to be the same. So now to graph, and this grid is very, very small. So I'm going to make it bigger, clicking on this. And once again, I need to get the parabola, so I get the U-shaped graph, and I start by graphing the vertex. And up here it tells me, click the graph on the vertex of your parabola. So I need my vertex to be 2.5 and negative 0.25. And if I look up here in the corner, it tells me what values I'm at. So that will kind of help me. So I need to be at 2.5, negative 2.5, negative 0.25. So right there. And then I can pick any of the other values. So I can go to 2, 0 and graph that. I could go to 1, 2 and graph that. So whichever one's easiest, right here I have it at 2, 0. I could even pick 3, 0 or 4, 2, because if you see my graph at 1, and I think I missed, my vertex clicked off a little bit, so I can take and drag that over, and now I should be at the right spot. Alright, so now if we look at 1, I'm up here at 2, so that would have given me the same graph. Alright, let's look at his next example. In this video, we will look at a modeling example using a quadratic equation. It says the cost C in dollars of manufacturing X bicycles at a production plant is given by this quadratic equation. We are asked to find the number of bicycles that must be manufactured to minimize the cost. And whenever I see minimize or maximize, that's a clue that I'm going to be trying to find that vertex. Now, what does this graph look like? Well, since this A, the number in front of the x squared, is positive, thinking about my bank account, that would make me smile. So my graph is going to be a parabola that opens up, which means my vertex is going to be my minimum point. So that's what I'm looking for. And it's asking me to find the number of bicycles. And up here they tell me that bicycles is my x. So I need to find the x value of my vertex, also known as my axis of symmetry. So before I start, I want to identify my A as 3, my B is negative 1500, and my C is 198,000. To find that axis of symmetry, that x value, I use negative B over 2A. Well, negative times negative 1,500 is 1,500. And I'm going to divide that by 2 times my A, which is 6. And 1,500 divided by 6 is going to give me 250. So that's how many bicycles I have to make to get the minimum cost. So I'm going to enter the 250 here. And then it's going to ask me what is that minimum cost. So I'm going to use my calculator. I'm going to put 250 into this equation, both places that I have an x. And when I do that, I end up getting $11,000. So when I enter that here, I get the answer correct. So hopefully this helps you with solving your questions. Again, we're working with minimums and maximums. We're looking for the vertex and answering those questions about the graph. If you have questions, ask me in class.